Here we have CO2. The first thing I would do is draw a skeleton of the structure. CO2, it's made up of one carbon and two oxygens. First, we need to determine which one is the central atom. The central atom will always be the least electronegative element. If we look at the periodic table, fluorine is the most electronegative, and in short, the closer you are to fluorine, the more electronegative, and the further away you are from fluorine, the less electronegative. We're comparing between carbon and oxygen. Oxygen is right next to fluorine. Carbon is further away, and carbon is less electronegative, and it's also our central atom. So since we know that, carbon is our central atom. And then we have 1, 2. We have two oxygens surrounding it. So we got one oxygen there, and then another oxygen here. And now that we have the skeleton of the structure made, we need to add up the total number of valence electrons. Oxygen is in group 6, and it has 6 valence electrons. And carbon is in group 4, and it has 4 valence electrons. So we just need to add that total up. So we have carbon. We know it has 4 valence electrons. We only have one carbon here. So 4 times 1 equals 4. We have oxygen. Oxygen has 6 valence electrons. We have 2 oxygens. 6 times 2 equals 12. 12 plus 4 is 16. So we have 16 total valence electrons, or we can also say that we have 8 pairs of valence electrons. So I'm going to write 8 pairs right here. The first thing I'm going to do is connect these with a pair. So we got one pair here and another pair here. Just by connecting them, we used 2 pairs. That's going to leave us with 6 pairs left over, and we're going to need to add the remaining pairs on the terminal atoms as lone pairs of electrons. So we have 6 pairs total, or 6 pairs left over. So we got 1 pair, 2 pair, 3, 4, 5, and 6. So now we have used our remaining 6 pairs of valence electrons, and we have no more left. And now we just need to make sure they are properly balanced. So if we check this oxygen right here, it has 2, 4, 6, 8. It shares 8 total valence electrons. And whenever it has 8 total valence electrons, that means it has an octet. And if we check this carbon here, this carbon only has 2, 4. This carbon has 4, so we'll come back to that. And this oxygen over here has 2, 4, 6, 8. This oxygen has 8 valence electrons, or an octet of electrons. But now what we need to do is rearrange these electrons so that this carbon can have 8 valence electrons, or have an octet of electrons. So if we erase this lone pair right here and make a double bond here, also known as a pi bond, this oxygen right here is still going to have 2, 4, 6, 8. It still has 8, so this oxygen is still good. But now this carbon over here has 2, 4, 6. It has 6 total valence electrons now, which is better than before. But it still needs 8. So we're going to have to do the same thing here. We're going to have to erase this lone pair of electrons and make another double bond, or pi bond, over here. And this oxygen over here still has 2, 4, 6, 8. It still has 8 valence electrons, which is good. And now this carbon here has 2, 4, 6, 8. Now this carbon has 8 total valence electrons, or an octet of electrons, and this CO2 structure is done. That's it. We have HCN. The first thing I would do is draw a skeleton of the structure. HCN, it's made up of 1 hydrogen, 1 carbon, and 1 nitrogen. As we know, hydrogen will never be the central atom, so that means we need to determine whether carbon or nitrogen is going to be our central atom. Fluorine is the most electronegative, and the further away from fluorine you are, the less electronegative, and that also makes it the central atom. So we're comparing between carbon and nitrogen. Carbon is farther from fluorine than nitrogen is, so that makes carbon less electronegative, and it's also our central atom. So we know that carbon is our central atom, and then we have hydrogen and nitrogen surrounding it. And now that we have the skeleton of the structure made, we need to add up the total number of valence electrons. Nitrogen has 5 valence electrons, carbon has 4, and hydrogen has 1. So we just need to add that total up. So we know hydrogen has 1 valence electron, and we only have 1 hydrogen here, so 1 times 1 equals 1. carbon has 4 valence electrons, and we only have 1 carbon, so 4 times 1 equals 4. And nitrogen has 5 valence electrons, we only have 1 nitrogen here, and 5 times 1 equals 5. Now we need to add these up. 5 plus 4 plus 1 is 10. So we have 10 total. We have 10 total valence electrons. Or instead of saying 10 total valence electrons, we can say that we have 5 pairs of valence electrons. So I'm going to write 5 pairs right here. We have 5 pairs. The first thing I'm going to do is connect these with a pair. So we got 1 pair here and another pair here. Just by connecting them, we use 2 pairs. Now we need to add the remaining 3 pairs to the structure as lone pairs of electrons, and we need to add them to the terminal atoms. Hydrogen can only have 2 total valence electrons, or 1 pair, so we can't add any lone pairs to this. Once it has 1 pair, hydrogen is good, so we need to we're going to have to add the remaining 3 pairs to the nitrogen. So we're going to put 1 lone pair here, another pair here, and another pair here, and now we use our remaining 3 pairs. And now we just need to make sure all of the electrons are properly balanced. As we know, hydrogen can only have 2 total valence electrons, or 1 pair. So this hydrogen is good. This carbon has 2, 4. It has 4 valence electrons, so we're going to come back to this. And this nitrogen here has 2, 4, 6, 8. It has 8 total valence electrons. So this nitrogen is good. But this carbon needs 8 total valence electrons, which is an octet. So we're going to need to rearrange these. So if we erase this pair right here, this lone pair, and make a double bond here, now this nitrogen still has 2, 4, 6, 8. The nitrogen is still good, but now our carbon has 2, 4, 6. It has 6 total, so the carbon is better, but we still need to have 8. So if we erase this lone pair right here and make a triple bond here, now this nitrogen still has, 2, 4, 6, 8, so the nitrogen's still good. But now our carbon has 2, 4, 6, 8. Now the carbon has 8, and this structure is complete and it's good to go. I want to thank you guys for watching this video. I hope it helped out a ton. Please hit the like and subscribe button, and peace.